All right, so today we have Sudhir Hasbe, Chief Product Officer at Neo4j, and we'll talk a little bit about graph databases, but I have him here today because he's industry veteran in the data management space, and while there's so much excitement around generative AI and AI in general, obviously everything starts with data, and so we're going to try to kind of give you an update of data management systems as of late August 2023 and how they and how to think about them in light of generative AI. And just to kind of place Sudhir Hasbe's background in context, I went to his LinkedIn profile and his tagline still talks about hashtag BigQuery. So, and that's because Sudhir for a long time ran product management at Google Cloud for data management. So long-winded intro. Sudhir, welcome to the Data Exchange podcast.
Thank you. Thanks a lot, Ben, and looking forward to conversation today and should be an exciting one.
All right. So first off, let's start with vector search and vector databases. So let me give you a few facts about these systems. One, there's a lot of them. There's a lot of startups. There's proprietary systems. So that's fact number one. Fact number two, it seems like they've become kind of like the starting point for, I wouldn't call it the hello world application for LLMs and generative AI, but basically one of the first applications that people try to build is how can I use an LLM to talk to my own data? And the natural thing they do is put their data in a vector database. And for those of you who aren't following this space, that means you take a bunch of embeddings, you put it in a system where you can index them, and you have basically the canonical workload for these systems is nearest neighbors. And so they become kind of like the natural first thing that people will try. All right, so I have an LLM, it's fun, I'm talking to it, I'm sending it data through prompts, but at some point I need more data to interact with, and so vector database it is. So Sudhir, question one, in your mind, so what do these systems do well and what do you want them to do better?
Yeah, no, I think just to be like, just adding one more point to the conversation, large language models have this inherent challenge of context, and they can only keep context for so long. There are limitations of how many tokens they can take and all that. Like all these systems are increasing tokens, but if you wanted to have long-term memory and storage capability, they don't inherently have that. And this is where vector databases with vector storage became really an alternative way of storing information for long periods of time. And like similarity searches became the way you could find the information that you would have already got from large language model and stored it in form of embedding. So that's what it is. I think these systems are great for doing one thing and only one thing, which is similarity searches, as we talked about. Take the embeddings from LLM, store it here, and do a search again on that particular data set over a period of time. This is a good, as you said, for a hello world application, that looks like a really good solution. But when we think about having an enterprise grade solution for generative AI application, where your data is stored in various different complex systems, you already have a lot of context on how the relationships or how the data is being used within your environment. And you need to go ahead and pull that data as well as have this vector search capability. I think the question is, how do you build that complex application in environments in enterprises? And that's where I think the key challenges come for organizations.
And in my mind, at some point, they also need to do a better job in terms of real-time updates, right? So because knowledge changes obviously all the time. I mean, one of the major breakthroughs that Google had was their ability to index the entire internet in minutes, right?
Yeah.
And so same thing will have to happen with these systems. Right now, most of these systems actually assume that you already have the embeddings. So you're responsible for generating the embeddings, and then you load it into their
Then you
system.
load it into it. So I think that's right? So vector database itself it's just a storage system and retrieval system. So you first have to go to the large language model, generate all the embeddings, then store them, and then you can only extract what embeddings you have stored already in that context. And without having any additional context, the only way of figuring out what you're looking for is a similarity search. And I think if the world needed just one single type of a retrieval mechanism, which is a search based on that vectorized information, then of course, then that is what the system is ready to do. But it may not be able to solve various different use cases in enterprises.
And like you said, right now, right? So it seems like the canonical workload is the only workload, which is nearest neighbors, similarity search. So that's why a lot of the focus of these systems are in scaling to as many embeddings as possible, right? So the more PDF files or whatever it is that you want to embed, they can handle. And then the ability to retrieve the information you want fast. So query speed, right?
Exactly.
Now,
I can actually even if you look at even search technologies, I will talk about Elastic. Elastic has been there forever, and they have various capabilities that Elastic has added over many, many years. And it is not just I want to find a similar string. You can also do filtering and say, hey, these entities need to be in documents indexed. And then I can go ahead and say, find me red dresses, but I only want to go ahead and have things that are indexed this way. Along with the simple search, they also have this ability to index and filter and all of that stuff. So if you think about even in a search scenario, we a lot of times have ability to filter and ability to enable different kinds of capabilities that various databases provide. And so the real question here comes is do you just need a nearest neighbor based search, or do you want this additional ability to filter in Elastic's case? But think about Postgres and PG Vector, and that has Postgres now gives you full relational model, and then you can do filtering and other capabilities with that. Or in case of Neo4j, it will be a knowledge graph, and you can use the knowledge graph traversal model to filter and identify data, and then you can go ahead and still do vectorized search. So I think the real question here is for enabling these end user use cases. Do you need just a very dedicated, only single use case or single pattern based similarity search like nearest neighbor? Or do you need all these different databases that can provide additional capabilities along with vector searches? I think that's the key difference that you're seeing in the industry right now.
So to their defense, the vector database systems, right? So they have been thinking about metadata filtering, and I think
absolutely
some of these systems already have it. They also actually this even predates ChatGPT in November last year, right? So they have also been thinking about hybrid search. Here, hybrid means a combination of neural information retrieval, so the embeddings, and BM25, right? Which is classic keyword search. So they have been able to do that, right? So the question, Sudhir, so the main question people seem to want to ask is, do I need a separate system? Because if you look at, as you mentioned, Elastic, right? So Cassandra also now has it. MongoDB,
Mongo has it.
The RocksDB people are adding it, and I'm sure most other systems will add some notion of hybrid search, right? So this BM25 plus neural information retrieval. Yeah. So the question is, do you think over the long term we'll see separate systems dedicated for vector search?
I actually, I've been talking to a lot of customers on various different use cases and what patterns emerge, right? I think in long term, in production workloads that people will build in enterprises, they will have requirements for different things to be done along with the vector search. So I think it will become more of a vector search becomes a capability in a database that you want for the job that you're doing, whether it's Mongo, whether it's Elastic, whether it's Neo4j, whether it's Postgres, and having vector search as part of that and leveraging LLMs and building Gen AI application, but using the right tool for your use case actually is going to be more popular when things get into real production and real workloads when you get there. Now, of course, till the time people are trying things out and they want to go ahead and make sure that vector search is what they want to use and experiment with it. I think you will have this early adoption cycle. There may absolutely be new set of use cases that we haven't seen before that only need like the similarity searches, and then you need to store all of this data in just a pure vector store and then do it. It's possible. I haven't figured out those yet, and I talked to a lot of customers and I haven't seen many of them figured out yet. So I think we just need to learn as the market evolves. But it seems to me personally that like vector search will become more of a feature of an existing set of databases rather than having a separate category of a database which is just purely vector search and without anything. Now, over a period of time, Ben, I do think convergence happens. I'm pretty sure vector stores will add more capabilities that will match similar to whether it's Elastic or whether it's Postgres kind of capability, metadata-based filtering and some other things they may add. And that may converge more towards like I will enable different workloads along with simple search or single search kind of a model. But I do believe for now, it feels to me like it's more of a capability of one of the existing categories of database. And we have a database for everything in this world. So it feels like more of that. And this is why you're seeing every database company looking at like adding vector searches to it. We actually announced our vector search on 22nd August. So I think we are in the same category.
Yeah, and I think Sudhir, as someone who's been in this space for a long time, you can attest that in the beginning there's always excitement around these new systems because they're purpose built.
Yeah,
and that means they're very good at what they do, at that whatever specific thing they do. And also they're very easy to use for that specific workload, right? So now you mentioned Postgres. So Postgres, actually, you now have two options, PG vector and PG embedding for doing vector search. But then, your typical developer will say, well, that's great. And I really admire Postgres because it's got a great ecosystem, rock solid, so many production use cases at scale, and so on and so forth. But I'm just a lowly developer. There's a lot of knobs to turn with a system that's rock solid, that's been in production for so many years, and so many plugins, right? So on the other hand, you've got these purpose-built systems that I can try, and I can create an MVP, right? And the MVP looks good. But then the question is, over the long term, what happens to that MVP when you want to really do it at scale? And now the question is, do you want to maintain two separate systems? Or does your old system get to the point where it can more or less match your purpose-built system for that one thing it can do, right?
I agree, actually, Ben. So I was talking to a customer out of Sweden, and we were brainstorming, what the challenges were, use cases with LLMs and what they wanted to do. And they do a lot of scraping of like information from different websites. This is retail kind of a use case where they help with payments and all, but they try to go and scan through, let's say, an Amazon page, and they try to figure out how they can simplify checkouts and stuff like that. And the thing was, they can take all of that page and they can store it as a vector embedding, and then they can, in future, when they come back, they can quickly search on the page wherever you're trying to search for something and then help check out and all that. And the discussion was exactly this, like, hey, should we just use one of the vector databases, leading vector databases, to store all these vectors, and then we can go search for it and we can store it. And when we started discussing more on the use case, actually their head of product was like, hey, but don't you think it will be super expensive every time somebody lands on a page to convert into a vector, search if in our database there is that particular vector embedding available, then we go ahead and look into that, and then decide how do we check out automatically and all. Don't you think we should, like, first filter it down to set of which sites we have already been, and if we know this is the site and this is the thing, and if we can auto check out, you don't want to again do the embedding to the LLM, and because it's expensive to create embeddings too. So shouldn't you filter first and then go to create embedding and do a search, versus doing search every time, create embedding, search every time, then decide? That would be a really expensive process to go do that. And the thing was, do you go to knowledge graph first to figure out, filter down, and if you can't be successful, then do embedding and vector search, or do it the other way around and all? So I think it's also, one thing you mentioned was, it's easy, let's get started, but in long term, do you need two systems or one? The second angle to this is, okay, what is the more cost optimum way of building the system? Like, to begin with, you can experiment with one pattern, but in future, when you productionize it, you have to figure out, how many times are you going to create the embeddings? How do you want to go ahead and search for them every time? Or do you want to have a different path where you can filter first and reduce your amount of embeddings you have to create and the searches you have to do? So I think those are the considerations in real enterprise Gen AI applications that people will have to think about.
Yeah, and I think the other reason, obviously, why people start with this new specialized systems is because they've made a concerted effort to integrate with the ecosystem, right? So the LLM ecosystem. So
absolutely,
many of the examples that you work on there point to these specialized systems. They're not gonna say, okay, so now let's build an example application, spin up your Postgres.
Exactly.
So it's much simpler for the tutorial to say, here's a much lighter weight special purpose system, right?
Absolutely. And I think that's the advantage of the early use cases and POCs and people that are trying to learn the system and all that. Absolutely, that helps because it's simplicity, right? You can just go and download some code and just start playing with it and stuff like that.
And I guess, Sudhir, just like anything else, the question comes down to, you've got a purpose-built system. Can this purpose-built system add more capabilities?
Yes.
So that it's not just a one-trick pony. Or you have proven systems that will add this one thing that this purpose-built system can do. So the question is, over the long term, which will more likely happen? And I take it that you're saying that it's more likely that the systems that are proven, have been in production, can do many things, will add this new capability.
So I think I will say this. In eternity, we all will build the same thing.
Yeah.
That's my theory of equivalent of relativity about software development. We all in data space are going to build the same thing. But just look at in last 6 months, how many of these existing systems were able to add vector support within their databases? Like, take a look at it. Almost every major database provider has already added it. So I think what I believe is it's much easier for the core database companies to add vector indexes and vector searches within themselves than for vector store, like a dedicated only vector store, to add all the capabilities that these different systems can add. And it's just like, I'm pretty sure in eternity they can do anything, and I'm pretty sure like Postgres or anybody can do all the capabilities. So I don't think that is a problem. I think it's much easier for existing proven databases to add vectors. We were able to add vector support in our database in less than 3 months and then ship it, and it's available for all customers now and all that. So I think, and we will only improve from here. We can add more capabilities. We can blend capabilities as we move forward between knowledge graphs and vector searches and the explicit relationships in graphs and implicit relationship of search, we can bring a lot of these capabilities together for many different use cases. So I think that's what I mean is like it's easier for database companies to add vectors, but the vector databases to add all capabilities of a relational database, a NoSQL, Mongo-like system, search-like system like Elastic. All of those are going to be our knowledge graph, like graph systems like that. So I think that will be much harder, I think. But again, I am a little biased, but I think that's what I feel is
and that's why I keep making this distinction of, I think the vector databases are super popular because they are easy to use and easy to get started, right?
Yeah.
But then, we cannot kind of ignore the fact that when you productionize things, then now you have to go through IT checklists and requirements and a lot of capabilities that set aside the database capabilities that these systems have, but what about the enterprise requirements that they have, right?
And also operational management.
Yeah.
Like if you are in a large enterprise where you have a central team managing all these databases, and adding one more new database to that portfolio is an expensive task. One is the enterprise security requirements, all that we met. But second, not just feature set, but just operational management and how you enable that. That also is a complex environment. Now, in a fully managed database world in cloud, I think that becomes easier, but still you have to go through like operational management of some of those databases too, right?
And let's not forget cost as well, right? Because even in the managed service, what if you have what if your managed service, an existing database system is a managed service and adds this capability? Maybe it's cheaper to do it that way.
Yeah, because you're leveraging the same system for multiple use cases. You can compute allocation becomes an interesting thing. You can share it and all that. But you're right, yeah.
Yeah, and the assumption here is all these systems will get a lot of usage just because so many people are excited about generative AI, right?
Yeah, which is great. I think this is a good thing for everyone. Like I think the more innovation that happens because of generative AI and new next generation applications get built, it will benefit everyone, including the vector databases, other databases that also support the similar capabilities. I think people will pick and choose. So it's good for the whole industry.
All right, so topic number 2, analytic databases. And for people who haven't been paying attention, right? So let's tackle kind of the medium-sized data space first, right? So a lot of people are probably familiar with SQLite, and probably a lot of people use SQLite without actually knowing they're using SQLite, right? So it's like this super popular database, but in reality it's really optimized for transactional workloads, right? So it's an OLTP system. More recently, there's a system that's open source called DuckDB. Think of it as like SQLite, but focus on analytics, right? So OLAP. I mean, the reality is, and Sudhir can attest to this, is that my handle on Twitter is @BigData, but the reality is probably most people are in the maybe a few terabyte world, right?
Yeah.
That's the reality. I mean, you can tell me. So what was the distribution of users or usage in BigQuery?
I don't think I can share all of that, but no, actually, just to be clear, right? Like if you look at customer and of course there is large customers, we had exabyte plus customer, we had like hundreds of petabytes based customers, but like long tail of customers, actually many or most, maybe 70-80% of them were having less than 10 terabytes of total data, and they're going to use that for marketing analytics and some analytics around their customers and stuff like that. So I think there's a massive distribution. Like when I say 70-80%, is the smaller customers that are using it for long tail use cases. And then also one of the other things that's an important concept is, even when you have lots of data, for a specific use case, how much do you really use? The customer that has 100 petabytes of data or like petabytes of data on an individual use case, when you're trying to serve some recommendation or we are trying to serve something, how much data do you actually use in an individual use case? That's a real important question. And that is not in tens of terabytes. Like only talking to one large customer where they had one single table that was a petabyte scale table. It was all clickstream coming from all of their front doors, because that was petabyte. But most other tables are not more than a terabyte. So if you think about this in-memory DuckDB kind of a solution, the question you have to ask is, for an individual use case, how much data do you need? Your data lake may have like petabytes and petabytes, but if your use case only needs like small data, then you can actually use systems like these to accelerate it.
Most of the questions you'll ask probably at some point, if you're asking ad hoc query type questions, maybe you'll hit the really big tables, but most of the time you've kind of know the tables that you need to hit, and they've been kind of processed for you. Maybe someone even designed a nice star schema. Yeah. So they've been kind of processed to the point where they can probably fit in memory.
Yeah. So I will give you an example. Actually, before joining Google, I was VP of engineering at Zulily, and it's an online marketplace where we had 18,000 plus vendors sold things on our website. And one of the main use cases was providing vendors with analytics on the site. So you can come in and say, what products, how much did I make, how much did I sell? And we had like really large amounts of data in this sales database we had. But normally everybody cared about the last 3 months of sales by customer and some like by product breakdowns, right? So what we did actually was we put all the data in BigQuery at that time, and we basically created a smaller data set in Postgres, which actually allowed us to do some simple analytics. Of course, it was not that performant. If I had DuckDB that time, I would have used DuckDB to give really high in-memory performance on that. And the number of people that actually changed that filter to say, no, give me all-time data to query was negligible. It's less than 1% of the traffic really wanted to see the whole thing. And when that happened, we sent it back to BigQuery, and it was actually large query. It came back in few seconds, but customer knew, or the vendor knew that, oh, I'm running a massive query now and all. But this is what I mean. Like, if you look at use cases and what people are trying to do, most use cases don't need like terabytes of data, and up to a terabyte, you can cover most use cases. So I think this is where I come from big data world. I was working on Hadoop, then I worked on BigQuery. I managed the product for the whole Google Cloud on all data analytics, including
and your LinkedIn tagline talks about #BigQuery.
So I'm still not disconnected from it, right? So, but that's what I'm saying. But and also the founder of MotherDuck, which is actually DuckDB based company, he was the first engineer on BigQuery. So actually we have these conversations, and that's the key thing. It's not about how much data you store, but how much data do you need for use cases, and how do you power that real interactive kind of an experience is actually where the world needs more problem solving. And I think that is where DuckDB-like systems are going to play a key role.
And kind of connecting this to our earlier points about vector databases, DuckDB also fits into this world of easy to use, easy to get started.
Yeah.
And basically has an ecosystem now. So there's a lot of examples and tutorials, and so very kind of low barrier to entry.
Yeah.
Then as you use it, you might realize that, hey, I might be able to support my little whatever it is marketing department of a few analysts using DuckDB, and then you take it from there. So clearly it's something that has resonated with developers, right?
Yeah, absolutely. I've not seen this much excitement in the analytics world before with developers, I think. And also it enables a different class of users for analytics in general. I've always been saying there is analytics that analysts run, like, seconds worth of queries, and then there are analytical applications where you want to build a real-time front-end application that people can use and consume. And that is actually where the excitement is. So developers building analytical applications is where the real excitement is, I think.
So how does this, does it then start colliding with some of these systems like Clickhouse, Druid?
That's the same category of problem solving, right? I think Druid was the first one in the Hadoop world where it started looking at these real-time use cases, and we worked with a lot of customers that actually use Druid for solving this real-time use case. We had all data in BigQuery, and we had like
no joins.
Yeah, because but the thing is, they don't need it. Like when they prep the data already in the data lake and warehouse, and then move it here to serve. And so they've already pre-processed it. And so I think that's where it is. And I've seen Clickhouse being used in companies like Spotify, where they basically took the data from BigQuery. They had like Clickhouse experience for external facing applications. There are tons of examples of that.
So you think that DuckDB can eat into some of those?
I think it's a good option for those kind of use cases, right? I think it allows you to go ahead and leverage that, and some of the work that innovation that's happening with MotherDuck and DuckDB around how do you build a more scalable backend and for cloud service and all that, that will solve more of the problems. But I do believe that based on your size of data, based on what use case you're doing, and the excitement around DuckDB, I think developers will be able to solve those kind of problems with really low friction, is what I believe. I think that's where the interest would be.
Yeah. And now we need DuckDB to do vector search, huh?
Let me call some friends and see if we can get out. I don't know, I think.
All right. So the next topic is Lakehouses. And full disclosure, I'm an advisor to Databricks, and actually I was a part of the team that wrote that post, What is a Lakehouse? But it seems like that concept has really resonated, and I want to get your take on Lakehouses, but only if it's a positive take. No, just kidding.
No, actually, see, I always think about things from a customer and user perspective. Like I don't think our point of view actually matters. And so the main point here is the size of data in organizations is growing, and you want a low-cost storage, and you want different use cases to be run on the same data that is being stored. This is our philosophy in Google. This is the same philosophy that Databricks has with Delta Lake. And if you look at the whole model, even in AWS, like how S3 is thought about and how you can run different engines, it's a very similar philosophical model, which is large amounts of data, ability to run different workloads. And Lakehouse brings some of those warehouse-like capabilities of looking at data not as files, but as tables and rows, and putting some cataloging on top of it, and making it real system that you can use. And I fundamentally think that is exactly what customers want, right? Like this was the world where in past 10, 15 years back, I'm dating myself, people had this warehouses like Teradata, and they had that Hadoop and two different siloed worlds. And over a period of time, some of that workload moved to cloud with like...
Oh, no. At some point, the Hadoop people, there was some excitement around systems like Impala, right?
Yeah.
So basically now this thing can do something like a warehouse.
Yeah.
But it didn't really come to fruition, right? So.
But what happened over a period of time is all these things, as they moved in cloud, there was a next generation innovation and movement. And like as large lakes, data lakes started expanding, and in different environments that were different. But the fundamental idea of like having a single storage system that's low cost and running different modalities of compute, like I should be able to run SQL queries, I should be able to run Spark, I need to be able to run machine learning and AI models directly on top of that data. That multimodal execution, but on the same set of data, is super powerful. And I think about Lakehouses that architecture that enables that. And this is why I will also bring back my earlier discussion we were having with DuckDB is like, now imagine all your data, petabyte scale, is sitting in Delta Lake, Iceberg, like whatever is your Lakehouse storage system is. But I could run different query engines, which are optimized for different workloads. And if DuckDB allows you to build like real-time analytical applications, I can do large-scale queries based on like a warehouse kind of an engine that is there, or I can run Spark for some other workloads, and I can use like Gen AI machine learning model for training. Like all that from a single storage system absolutely is where the market is, and that's what customers expect from.
And by the way, one of the subtle things you imply here is, you've got then now this source of data where you can do multiple things, but now you have the same catalog, you have governance, you have
common governance,
security,
common catalog.
right? So everything managed. And it all makes sense because you have complete visibility. Maybe you have orchestration across multiple workloads even.
Yes.
And
also,
which, by the way, everything I'm saying is real. You just go to databricks.com. Just kidding.
I'm pretty sure I can send you some other sites too. But my uber point is, keeping vendors and solutions aside, it's not just cataloging, but also how do you track lineage across end-to-end? All of these systems where you can say you got this data from here, you processed it with Spark, or you processed it with a query engine, and then you use it for BI or AI.
Makes it much easier for you to debug your pipelines, right? So, which actually, which begs the question, then why don't you just do vector search on this system, right? I mean, at some point, do you really want a separate system? Okay, so now I'm about to do vector search. Let's pull data out of this system, generate embedding, put it in here, right?
I love that idea that you're bringing, but the problem is, and this is physics, right? I'm a physics major, and everything that finally physics comes in the way, which is the reason why you have a vector storage and vector indexes. I would say, I don't think you need separate storage systems, but different indexing schemes have to be there. So if you basically said your data was in, let's say, large scale lake, but you index it using a vector index to go ahead and optimize search, I agree. I think that's absolutely the model we should all look at. When I talk to customers and think about knowledge graphs and graphs, that's what I talk about. I talk about, hey, it's not about taking all your lake and putting it to a graph. Like, that's not the thing. But think about what kind of a graph index can you create, wherein you can take all your data in a lake, extract the key entities and relationships, and then create an index on top. So now you can do traversal. Now you can do some graph analytics, centrality algorithms, shortest path. All that you can solve with, but it's not about replicating the whole data and creating multiple databases and all that. That's not required. So I think we have to think about the difference between storage of large amounts of data, but optimized execution engine for each one of them, right? Even in, I know you're a big fan of Databricks. Databricks also.
But this is you're describing basically the Lakehouse, right? So.
Yeah, exactly. That's what I mean. Like if you look at, even in Databricks case, the Delta Lake, the storage system, but the query engine that they're building, they are optimizing the query engine to work on top of all of that data and how it will come together. So you have to worry about how the queries become optimized over a period of time and what do you want to do with that, right?
All right. So then the next system I want to talk about is knowledge graphs. And as I mentioned at the beginning of this, when we were talking about vector search and vector databases, if you think about the Hello World application for generative AI, it's basically, let me use an LLM to talk to my own data. But then right now, for whatever reason, people are using vector databases to navigate their data. And I think part of that is, I hate to say it, Sudhir, but knowledge graphs are maybe more opaque, maybe harder to get started with. Maybe there's some concepts that get in the way. Whereas when people think of vector databases, oh, I have my documents, I generate embeddings, stick it in here, and now I can get started, right? So is it just a question of conceptually it's harder, or also maybe also there's fewer systems that are known to people. So in other words, as I mentioned earlier, if you're doing LLMs, go to any of these frameworks, they will give you examples where they talk to many different vector databases. I don't think many of them have examples where they go to a knowledge graph.
I think we have some blogs on how you do it.
But
no, but I think so. Let me cover the point that you brought up, and maybe that's why I have a job and I should do a good job at it. I think, see, the key thing is you're right. Like people who come from relational stores and like relational databases and all, when they look at graphs, graph has some level of learning curve for them, and they basically have to understand it. They stop thinking about rows and columns and think about like, entities and relationships and all that. It's a little bit of a paradigm. And I think our goal at Neo4j is to, how do we simplify that journey, wherever you're coming from, and then make sure that it's very simple to go ahead and get started with graphs and leverage the benefit of graph and get a graph epiphany. So that's one point. The second key point is, I think there was, when you started talking about vector databases and knowledge graphs, and there was like is it similar? Is it different? But I think the main point is graphs or graph technology allows you to have explicit relationships, right? You're basically saying, I can take an unstructured data or I can take structured data, entity and relationship, explicit things that you have. It's like, hey, you have clothing as a category. In that category, you have these different subcategories, and that you have sub products, and each product can be bought by different customers, and the customer can go through different steps in the journey, and I know exactly what that journey steps are. So it's very explicit how the relationship is maintained. On the vector side, it's all implicit relationships. So you're doing similarity searches, you're basically doing nearest neighbor search. So it is implicit, a close enough kind of a search rather than explicit. I actually think a combination of both of them enables a lot more use cases that people may in past have had tough time figuring out. It's like, if you could do structured and unstructured, traversals together, would that make life easy? Absolutely yes, right? So I think that's how I think about it, rather than looking at like what one versus the other is. And of course, as you said, right, like from vector databases in general, yes, once you are getting started on a new kind of a pattern, which is Gen AI, you feel that it is easier to start with the vector database only, rather than starting with creating an explicit graph and also vector. You can that seems like a little lengthier process, but on the other side, I think the kind of use cases you can enable will be a lot more, and they will be a lot more relevant to enterprises, and it will be more accurate. So if we believe in a retrieval-augmented systems, you're basically going to retrieve information and then use LLMs for more natural language experiences. I think having explicit relationships will give you much more accurate responses and results versus just depending on an implicit relationship that you have. So I think combination will be much more accurate, I think.
Actually, some people are already experimenting with, here's a prompt. I'll try to answer it with data from a vector database. But hey, if there's some information in some table somewhere, I'll also generate an answer that way, and I can fuse these two answers together. But Sudhir, I guess there's a bit of tooling that needs to be built and made open source or made easy, right? So in other words, I think there's already tools where if you have a data warehouse, you can turn that data warehouse into a graph somehow.
Yeah.
But now we need some tools where here's a bunch of PDFs. How can I magically arrive at a graph without being a graph or knowledge graph expert, right?
I actually
basically the rest of ecosystem of tools that people use don't require expertise in many ways, right?
And I think you will see more of that coming from us in coming weeks and months, because a lot of, if you look at all the Gen AI applications and use cases that we are seeing with our customers, we closed a massive deal in oil and gas space, and it was mostly take all their unstructured data and convert it into a knowledge graph so that they can then traverse through the the general relationship, but also take the unstructured data to search across and all that. And so as we build more of those, we will also start sharing how it was done, how easy it is to go ahead and build these systems. So we have done a lot of technical blogs to make it easy for people, but yeah, we'll continue on that journey. But I +1 to what you said, the more guidance, more open source tooling will absolutely help. So we are working on that side. And then also one of the other areas that we are focusing a lot on is how do we better integrate with LangChain? I think LangChain is like taken off as the, I call it the orchestration system for Gen AI applications. And so better integration and pre-built integration of that would be more helpful for users. Like we have already integrated Cypher language with LangChain, and
by the way, there's other frameworks you guys should look at. Haystack,
okay.
and semantic kernel, right? So from Microsoft. So last topic is a bit of a loaded word in the world of databases, and the word is multimodal.
Yes.
So let me give two meanings to this word, multimodal. Multimodal traditionally is in the database world, it can do multiple things, right? So it can be document store, relational, graph.
Yeah.
So that's the one notion of multimodal. The other notion of multimodal is just multimodal data. So I can put in structured data in there, unstructured data, which is text, images, audio, video. But that's kind of like the vision for the Lakehouse in some ways, right?
Yeah.
So whatever happened to multimodal in the first notion of multimodal?
Yeah.
Are we entering? Is that exactly what we were talking about earlier, which is basically, you take your existing database system and now it can do similarity search or nearest neighbor. So then there's a notion of multimodal in that sense, right?
I think you're right. But the question is, how do you implement these things, right? Like multimodal, in past multimodal meant like, oh, I have a one
never lived up to its promise. It was always like a not good enough. Not good.
I have a thesis. I have a thesis on this. I think what happened was people stored data in key value pairs, and then they built some algorithm saying that, oh, I can do, for example, I will take example of graphs, right? Oh, I can do graph traversal because I have this graph library on top of it, and I will just use my key value pair to keep jumping around. It's highly inefficient. So, but if the same system actually created a native graph storage system and a key value system and something else and allowed you to efficiently run all of those use cases, then of course it would work and it will be a real multimodal system. Like we were talking about indexes just earlier right now, right? It's like if you just stored everything in Lakehouse, like it's all Delta Lake, but anytime you want to do search, you don't index anything. You say, I will go figure it out on the storage system. Let's go figure it. Will not be performant. So I think the flaw is not in, and for small use cases, it may work, but like more production use cases, it's hard. So I think multimodal support, it all depends on how you make it happen. In our case, what we did was for vector support, we have a different vector index. And so you can traverse through the graph as you want. If you just want to go ahead and search on the vector store, you have a vector index, we can search anything and respond to you. So I think having that different storage system and different indexing mechanism for the workload that you need, that will actually solve the problem. But if you just said that I will store it in one form, I will just give you some kind of an algorithms to go run on top of it, but none of them will be more efficient when you run it. I think that is where we see problems. And we see this all the time where you have to make the use case really work for the customer. It's not I can support it. Like, can you make it run and does it actually enable it in the production environment is a real question.
And the other thing that never really took off was this HTAP system, right? So hybrid transactional and analytic. So OLTP and OLAP.
It's the same, but it's the same thing, right? Like I actually think like if you try to have both use cases, like I will tell you, like all the operational systems are row-based storage systems and analytical are column-based because you aggregate versus like that. Though that's the thing. If you said that you wanted to make HTAP systems work, in an ideal scenario, if you had both storage formats and you could go do it, then it would work. it would not work because the problem is the physics comes in again. Like you're picking your constraints and what you're optimizing for. And so when we were looking at this thing in my previous job, that's exactly what it was. It was like, hey, do you want to use Spanner? Do you want to use BigQuery? BigQuery for analytics, Spanner for operational. Oh, if you could hide the complexity from the customer behind the scene, and then we store behind on either of them, we could build one of the world's best HTAP system. It is complex, so you need to go work on that. But I think my thing is, that is what you have to do. You can't do it. In our case, in Neo4j, we have like graph data science, which is like an analytical engine. But for that, we created an in-memory storage system, which is completely different from the on-disk graph storage system for the database. And so what that allows us to do is I can run graph algorithms in memory in a completely different storage system. And therefore, we are able to do these two different kinds of workloads. But it's all because of how we store and how we optimize for each workload.
And actually, for our listeners who aren't familiar, I think a lot of people think of these graph databases as doing mainly analytics, but a lot of the use cases are actually transactional, as Sudhir pointed out.
Transactional and real-time traversal and all that kind of stuff, right? Like, tell me what is like, I am here, who are all my friends and who are they related to? And like this user came in, he picked this product and this product. What did he do after? Like journey analysis and all that. So it's more, or supply chain, like you can traverse through the whole path and say, what is the shortest path from here to there? Or I'm updating like all transactions coming through the website at the same time onto the graph and all that. So yeah.
Actually, let me close by kind of just kind of agreeing with Sudhir here on the challenge with the HTAP systems, because I think, if I'm not mistaken, the SQLite people just wrote a paper, a concept paper, right, where they say, okay, so this DuckDB guys came out, they're doing great, and this is what we need to do in order to be able to do what DuckDB does on the OLAP side. And then, by the way, basically they say on the paper, yeah, but if we do that, then that means the code base becomes much more complex, and doesn't that defeat the purpose of SQLite being so lightweight and so easy to use, right?
Yeah, exactly.
And so while they say, yeah, so maybe we'll explore that, but basically my takeaway is, don't expect anything drastic in the near future. Because basically, while they can conceptually do it, it's just, I mean, one of the nice things about SQLite is it is light. Yeah, exactly. And with that, thank you, Sudhir.
Thank you, Ben. It was great talking to you. And thanks to all your audiences too.